Hello and welcome to another episode of 3-minute videos with Nathaniel. Guess what I have now? It's two set shirt. And before we begin, I will say that this is question 1A from MAT Oxford 2030. But before we start this question, two set has this thing called Ling 40 hours, and it's about this god called Ling. It says 40 hours a day. So how many days a week is it? So how do we convert? So let's say 40 hours a day, then we divide by 24 hours. Obviously, there's gonna be a very ridiculous calculation, which is 5 over 3. So 5 over 3 days times 7 equals to 35 over 3, which is 11.667. What? 11.667 days a week? It's Ling, after all. If you break the rules of space-time, or if you redefine the week to be 12 days, then Ling can exist. Now, this function, fk, is defined by 3 values and a relation. Now, we need to find the sum of f1 to f100. How do we do that? First, we enumerate some values. So we start with 1, 1, minus 1. And then, since this equals 0, let's start from here. Then 1, 1, and then it's minus 1, minus 1. 1, 1, 1, 1, minus 1, minus 1, minus 1, minus 1, and these will all equal 0. Now what is the biggest power of 2 that is less than 100? So that means n must be less than log 2 100. So the biggest one is 2 to the power of 6. Now let's calculate how many negative ones are there. So there's 1 in the second, 2, 3, all the way until there are 2 to the power of the n minus 2 ones. You see here, since this is f 2 to the power of n minus 1, there will be 2 to the power of n minus 2 ones just before it. Now, what is 2 to the power of 7? It is 128. How many ones would there be? 2 to the power of 5 is 32, which means you would expect 4 negative ones at the end of the chain. So, how many are there? It's the same, 2 to the power of n minus 2 ones as well. So that means if we start 2 to the power of 6 is 64, 2 to the power of n minus 2 equals to 16, but we end at 2 to the power of 7 is 128, 2 to the power n minus 2 will equal to 32. So there are 32 ones. And based on this calculation, 128 minus 32 equals to 96. So the chain of negative 1 starts at minus 96. So we calculate 96, 97, 98, 99, 100. So minus 1, minus 1, minus 1, minus 1, minus 1. We call that these chains of 1s and negative 1s add up to 0. So therefall, this chain of negative adds up to negative 5. So that means that basically the change of 1s and negative 1s will wrap up over each other until they equal to 0. Now what is the sum? Obviously it will equal to 1 plus 32 minus 5 equals to 28. Fun fact about 28, it's the second perfect number, meaning you add up its divisors, its proper divisors, meaning those that do not add up to the number itself, you get itself. The next few perfect numbers are 496, 8128, and 3355036. Perfect numbers, right? Since we are talking about powers of 2, perfect numbers also have to do with other powers of 2. In this case, 2 to the power of n minus 1. Its definition has to do with this, or Mersenne primes. But Euclid had already figured out the formula for perfect numbers, and the formula for Mersenne primes is like this. Substitute n to be prime in the equation. If n is composite, it will work. Sometimes it will return a composite number given a prime superscript. This might equal to 23 times 89, for example. But anyways, I hope you enjoyed this little equation relating to powers of 2 and where the chain of negative 1s start. It's a really cryptic answer and also a very beautiful one relating to powers of 2s. There you have it. I think you might like other videos on this series called MAT Oxford Answers with Nathaniel. I hope you like it, and